All right. Now let's have a look at question 5 on concentrations. And this is not a difficult question, but there is quite a bit of work involved. So the important thing I want you to learn in this question is how to solve a question in as little space as possible. Now, there's nothing wrong with taking up a lot of space, but you need to understand how to lay out your answer in such a way that you can access the information when you need it later. Because the question is so long that it's very easy to write down your answers on page 1, and then by the time you get to page 5, you can't find the answer for page 1. So you want to make sure that not that you take up less space, but that your answers are structured in an easy way where you can find them. So let's begin. Question 5 says to you, we've got NaCl powder and we've got sodium sulfate crystals. So what this means is for every mole of sodium sulfate you have 10 water molecules around it. But all in all, I know it's surrounded by water, but it is a dry powder particle. Okay, it's a crystal. Okay, so it's not wet, it's dry. And it must be mixed to give you 100 kilogram mixture of salts that will contain 2.8% sulfur. All right? And they say to you calculate the mass balance. I mean, that's a super vague expression, so don't worry about it. But basically what they want you to find is what percentage of sodium is in the mixture. And you can see it's for 7 marks. So we expect to do a bit of work. So the first thing I always like to do is draw a picture and yeah. Okay. Another thing I want to mention is that this needs to contain 2.8% sulfur. Remember, it's just a mixture of salts. So we're not adding any water. It's literally just a mixture of salt on top of a different kind of salt. Okay. And so because we are talking about solid compositions, we discussed this in our semester test 1 preparation. But if someone gives you the composition of a solid, you are going to assume that that is a mass fraction. Okay? If someone gives you the composition of a liquid, it's also probably a mass fraction. Only for gases do we have mole fractions. Okay, I hope you are fine with that. So let's draw a picture quickly. So I've got a container. You'd think after all these times of drawing containers, I'd get better at it, but it's still just as bad as the first time. Okay, so here is my bottom layer of salt, and let's call this one the sodium chloride. Okay, that's the table salt. And then at the top, we've got another batch of salt, which is not copper sulfate, but sodium sulfate. Na2SO4.10 waters. Okay, so it's just dry salt on top of dry salt. And they want me to mix these salts in such a way that we end up with 2.8% sulfur. And remember, we've got a 100 kilogram mixture. So this is pretty straightforward, but I'm going to write it down anyway. The mass of sulfur over the total mass must equal to 2.8% or 0.028. Okay? And so therefore, the mass of sulfur must equal to 0.028 multiplied by the total mass of the salt mixture, and the total mass of the salt mixture is 100 kilograms. So it's 0.028 times 100 kilograms, and so the mass of salt should equal to 2.8 kilograms. I know you probably could have figured that out without 3 lines of working, and I just spoke about using less space for your answer, but I'm doing this for pedagogical reasons, to make things simpler to understand. Okay. So now that we've got that, they want to know what is the percentage of sodium in the mixture. So where do you even start with a question like this? All right. So I know what the mass of sulfur should be in this mixture, right? So just keep in mind, the only place where sulfur is going to come from in this mixture is from the Na2SO4. There's no sulfur in the sodium chloride. All of my sulfur comes from sodium sulfate. So do you agree? If I know how many moles of sulfur I have, then for every 1 mole of sulfur that I have, I'm going to have 1 mole of these beautiful crystals which are surrounded by water. Okay? If I know the number of moles of sulfur, I will know the number of moles of sodium sulfate. And if I know the number of moles of sodium sulfate, I can get the mass of sodium sulfate. So let me write down my logic here, right? Okay, so let's do this. If I know the number of moles of sulfur, that implies that I know the number of moles of sodium sulfate. Okay? And if I know the number of moles of sodium sulfate, then I can work out the mass of sodium sulfate. And if I can find the mass of sodium sulfate, then I can also find the mass of NaCl. And if I know the mass of NaCl and the mass of sodium sulfate, then I can work out the percentage of sodium in the mixture. Just like that, 1, 2, 3, 4, maybe 5 steps, and we're done with the question. So let's begin. Okay, I know what the mass of sulfur is. Converting mass into number of moles is very easy. Remember that the number of moles of sulfur is equal to mass of sulfur divided by molar mass of sulfur. So that's 2.8 divided by 32. And this is why you prepare the example beforehand. That gives you 0.0875 kilomoles of sulfur. But I know that the number of moles of sulfur is equal to the number of moles of Na2SO4.10 waters. I hope you understand why this is the case, right? Remember, I need 1 mole of sulfur. Okay, let me change my pen here. I need 1 mole of sulfur, 4 moles of oxygen, 10 moles of water, and 2 moles of sodium, all stuck together to give me 1 mole of the entire salt. So for every 1 mole of sulfur there's going to be a mole of the salt. Okay, I hope you're okay with that. And I can say, therefore, the number of moles of sodium sulfate dot 10 waters is going to equal to 0.0875 kilomoles. But of course, if I know the number of moles of sodium sulfate, let's go back up to my steps. If I know the number of moles of sodium sulfate, I can find the mass of sodium sulfate. So finding mass is very easy. Remember that mass of sodium sulfate dot 10 waters is equal to number of moles multiplied by the molar mass. So that's 0.0875 multiplied by, and now you've got to calculate the molar mass of this horrible crystal. So let me just show you how to do it. The molar mass of this horrible crystal is 2 times 23 plus 32 plus 4 times 16 plus 10 times the molar mass of water, which is 18. And if you put all of that into your calculator, you should end up with 28.12. No, sorry. Okay, I see I didn't calculate it, but that's okay. You can put that into this step here. Okay, and the outcome will be 28.125 kilograms of Na2SO4.10 waters. And that is the mass of Na2SO4. So what I'm going to do is I'm going to put this in a block just to keep things neat. Okay, I hope we are all on the same page. And actually, I'm going to expand it to include this. Okay, so I think we're on the same page. Let me just highlight this. Okay, so I can now say, therefore, the mass of sodium chloride plus the mass of sodium sulfate dot 10 waters was equal to 100 kilograms, right? But we knew this already. And I think that equation is... Oh, it's not written anyway. Okay, well, now you have the equation, okay? The mass of salt or table salt plus the mass of sodium sulfate is equal to 100 kgs. But I know that this number is 28.125 kilograms. And therefore, the mass of sodium chloride is equal to 100 minus 28, which is 71.825 kilograms. Remember, this equation comes from the fact that it's just a mixture of salts. There's no water involved. Okay, and let me put this in a block. So I think we are making quite good progress. We've essentially solved the mass balance, right? Because if you go up to the picture, right, they said to you that they've added these two salts, and we now know that we've got 71.825 kgs of sodium chloride, and we've got 28.125 kilograms of sodium sulfate, 10 waters. So we've essentially solved the mass balance. But now, I know that's what the question asks for, but the second part of the question is more important. What is the percentage sodium in the mixture? So now we've got something interesting coming. Now, I know that sodium chloride contributes to the sodium content in the mixture, and sodium sulfate also contributes to the sodium content in the mixture. But I only have the mass of this, right? I know the mass of the entire crystal. I don't know what mass of that crystal is being contributed by the sodium. So here's what I'm going to do. Okay? I'm going to say that let's start off like this. I'm going to do the calculation for sodium chloride first. And I'm going to say, okay, I know that the mass of sodium chloride is equal to 71.825 kilograms. Now, the number of moles of sodium chloride, and I know this is a bit strange, maybe this wouldn't come to you intuitively, but watch what I'm going to do. The number of moles of sodium chloride is 71.825 divided by 23 and 35.5 is 58.5, and that should give you 1.23 kilomoles of NaCl. But I know that for every 1 mole of NaCl, I need to have 1 mole of sodium ions, or sodium ions. So I can say the number of moles of Na, but the number of moles of Na equals, well, the number of moles of Na in NaCl is equal to the number of moles of NaCl, which is equal to 1.23 kilomoles of Na. And now I can say the mass of Na in NaCl is equal to number of moles multiplied by molar mass. So that's 1.23 kilomoles of Na multiplied by the molar mass of Na, which is 23. And that should come out to be why don't I have it here? Okay. 1.23 multiplied by 23. That should give me 28.29 kilograms of Na. And that is just for the sodium chloride. Okay. And you can see what I meant by trying to work in a linear fashion, right? Moving across instead of moving down. It just helps you save some space. Otherwise, you're going to end up using a lot of paper and it's going to become a bit messy. Okay, now let's talk about Na2SO4.10 waters. Wow, I'm so tired of writing this already. Okay, so I know that the mass of sodium sulfate with 10 waters was equal to 70, let's get this right. Mass of sodium sulfate is 28.125. So 28.125 kilograms. So the number of moles of sodium sulfate, and I think I actually calculated that up here, if I'm not mistaken, it's 0.0875 kilomoles. 0.0875 kilomoles. Okay. Now, I can say, but the number of moles of sodium in Na2SO4.10H2O is equal to 2 multiplied by the number of moles of sodium sulfate. So I hope you are with me on the same page. If I'm re-explaining this for the 10th time, I'm really sorry, but sometimes you just need it explained to you just one extra time and then it all comes together. Remember, for every 1 mole of this crystal, I need to have 2 moles of Na ions sitting around. And those 2 moles of Na ions are going to all combine with the sulfate and the water and make 1 mole worth of crystal. Okay, so the number of moles of sodium in this crystal is 2 times however many crystals there are. So that is equal to 2 multiplied by 0.0875 kilomoles, 0.175 kilomoles. Okay, and finally I can say that the mass of Na in Na2SO4.10 waters is equal to number of moles multiplied by molar mass. So that's 0.175 multiplied by that horrible molar mass. Oh, it seems I made a mistake here. Okay, all right. Let's get back into it. This is why your subscripts are so important. This is the number of moles of Na multiplied by the molar mass of Na. I'm sure you were shouting at me through the computer screen saying, you are making a mistake. So here we go. The molar mass of Na is 23. All right, let's try this again. 0.175 multiplied by 23. That's 4,025 kilomoles of Na. Okay, I hope you learned an important lesson here. Always write down your subscripts. So even here, this is number of moles of Na multiplied by the molar mass of Na. Okay, rookie mistake, hey? But anyway, now I've got the mass of Na in the sodium sulfate. So let's put a box around that. Okay, pull this down. All right, and now let's finish off this question. So the mass of Na total is equal to the mass of Na in sodium chloride plus the mass of Na in Na2SO4.10 waters. Okay, so that gives me, even here I made a mistake. Too many rookie mistakes today. This is kilograms of Na. Okay, so we've got 28.29 kilograms plus 4.025 kilograms of Na. And when you add those together, you get 32.315 kilograms of Na. But the question didn't say what is the mass of Na. They said, what is the percentage Na in the mixture? So if you want percentage, remember, the mass of Na divided by the mass total is equal to 32.315 kilograms of Na divided by 100 kilograms of the salt mixture. And then 32 over 100 is, of course, 32.315% Na. And that is my final answer. And I'll also put this in a block just to make things look a bit neater. All right. Okay, so that is our final answer. It was not as complex as I made it seem, but just keeping the maths correct is interesting and is a bit of a challenge. So hopefully you learned something from my mistakes. Thank you for watching, and let's move on to the next question.